Good morning dear students. Today class I am going to discuss on two topics mainly. First one free fall and second one to calculate the value of acceleration due to gravity on Earth's surface. From last class you understood that the apple's fall on Newton's head led him to think about his reason and the discovery of gravitational force. The gravitational force was the real cause. Now I am going to discuss on the topic what is free fall. When a body is under the influence of gravitational force of Earth only, then we can say that the body is in under free fall. Practically, it is possible under vacuum only, as there is always some air resistance present. Let us do an activity to understand the meaning of free fall. Take a stone, throw it upwards. It reaches a certain height and then it starts falling down. Why does the object come back? You know that it is due to the gravitational force acted by the earth to attract the stone towards it. And you learn that the earth attracts objects towards its center. The downward fall of the stone to which no any external force acts on it other than the gravitational force is an example of free fall. Then, what do you mean by free fall? Any motion involving a dropped object that is only acted on by gravity and no other forces is free fall. In practical situation, we have to neglect the air resistance to define the free fall. So it is clear that whenever objects fall towards the earth under the action of gravitational force alone, the objects are in free fall. For a freely falling object, there is no change in the direction of its motion. But one change is there. Can you say about it? It will be change in the magnitude of its velocity. How does it happen? It is due to the Earth's gravitational force. And you know that any change in velocity involves acceleration. Whenever an object falls towards the Earth, an acceleration is involved. The acceleration due to this gravitational force is called acceleration due to gravity. This means that the acceleration under free fall is acceleration due to gravity and denoted by small letter g. All three equations of motion are valid for objects under the free fall as they are in non-uniform motion. The SI unit of acceleration due to gravity is meter per second square, which is same as that of acceleration. When an object is under free fall, acceleration due to gravity is constant at g is equal to 9.8 meter per second square. For more understanding of upcoming part, it is the time now you have recollect these points, that is importance of gravitational force. One of significance of gravitational force is that it binds us to the earth. If earth had not gravity, what would happen? Life would not have been possible at all. If gravitational force is stopped, the terrestrial bodies all would have float in air. We know from Newton's second law of motion, that is, force is the product of mass and acceleration. Let the mass of that thrown stone in earlier discussed activity be small letter m. Then what is acceleration in its free fall? Let small letter g be the acceleration. More precisely saying, it is the acceleration due to gravity. You know why it is called acceleration due to gravity? Because of this acceleration is produced due to the gravitational force. By Newton's second law of motion, the magnitude of the gravitational force will be equal to the product of mass and acceleration due to gravity. Then F is equal to m into g, which is equal to g capital letter M small letter m divided by d square, which is already equated to the gravitational force, where capital letter M be the mass of the earth, small letter m be the mass of the stone, and d be the distance between the stone and the earth. Here, cancelling small letter m on both sides, we get small letter g is equal to g capital letter M divided by d square. Next topic is to calculate the value of acceleration due to gravity on Earth's surface. Let the same stone be on or near the surface of the Earth. Then the distance small letter d in previous expression will be equal to capital letter R. It is the radius of the Earth. Then by applying Newton's second law of motion, force acted on the stone to produce acceleration F is equal to mg. This is the expression 1. Now by applying universal law of gravitation, the gravitational force acted on the stone F is equal to g me small letter m divided by r square. This is the expression number 2. To get the value of g as the approximate value 9.8 meter per second square, we have to equate the above expressions. We know the values of g, me and r. Equating both expressions 1 and 2, we get m into g is equal to g me m divided by r square. Then g is equal to g me divided by r square. By substituting the values of g, me and r, we get g is equal to 9.8 meter per second square. This is the approximate value. It is the acceleration due to gravity and the acceleration felt by any freely falling body towards the earth. Value of g keeps changing due to the variation of Earth's radius, because the Earth is not a perfect sphere. The radius of the Earth increases from the poles to the equator. It means that if r is more, g is less, or if r is less, g is more. This relation is inversely proportional. So the value of g is maximum at polar region and minimum at equatorial region. Now you are going to study about what are the factors affecting acceleration due to gravity. Let us consider an object of mass small letter m, which is located on surface of a planet of mass capital letter M of radius capital letter R. Then what are the factors affecting g? First point is distance from the center of the planet to the center of mass of the object capital letter R, and second one is mass of the planet capital letter M. Capital letter M will be constant for each planet and g is the universal constant. From the expression g is equal to g m divided by r square, it is understood that acceleration due to gravity g is independent on mass of the freely falling body small letter m. What do you mean by a freely falling body? A freely falling object is an object that is falling under the action of gravity. No any external force is acted on this body other than the gravitational force. By forming the expression G is equal to capital letter G, capital letter M divided by capital letter R square, the small letter m has eliminated. So, G is independent on mass of an object. You understood that value of G of a freely falling object does not depend on its mass, that is, any object, big or small, experiences the same acceleration due to gravity under its free fall. Have you heard about Aristotle? Aristotle was a famous Greek philosopher and scientist. Aristotle's theory of gravity earlier stated that objects fall at a speed proportional to their masses, which means the heavier the object is, the faster it will fall under gravity. Heavier object accelerates greater under gravity was believed to be true in Aristotle's time. It was Galileo who conducted a thought experiment that disproved Aristotle's assertion. Galileo had dropped two balls of different masses from the Leaning Tower of Pisa to demonstrate that their time of descent was independent of their masses. What do you mean by time of descent? It is the time taken by a freely falling body to reach on ground. By this method, he supposedly discovered that the objects fell at the same acceleration independent of their masses. He understood that two different massive objects dropped at the same height at same time can reach on ground simultaneously by neglecting air resistance, and the acceleration produced by the objects are independent of their masses. Later on, Sir Isaac Newton could verify Galileo's experimental result successfully by using vacuum tube. So this Newton's experiment may be called as vacuum tube experiment. This experimental method can be understood by watching on the following video. Here, modern technological equipment is used. Let it be watched on it. Here, in second experimental condition, where vacuum is created in the tube, there is no roll of air which opposes the motion of the feathers and coins. You know, vacuum means space without air. In this condition, both feathers and coins reached on bottom of the tube at the same time. Their accelerations are independent on their masses. Now, you may have raised a doubt, why did the coins reach earlier than the feathers in first experimental condition? The answer is simple. As the feathers experience more air resistance than the coins, they take some more time to reach on the bottom of the tube. See this slide. What can you understand? Here a ball is allowed to fall freely. Initially it has zero velocity. At the end of first second, it has velocity which is equal to 9.8 meter per second. At the end of second second, it has velocity which is equal to 19.6 meter per second. At the end of third second, it has velocity which is equal to 29.4 meter per second. At the end of fourth second, it has velocity which is equal to 39.2 meter per second, and at the end of fifth second, it has velocity which is equal to 49.0 meter per second. Here, change in velocity in equal interval of time is same. What is it? It will be equal to 9.8 meter per second. Then what is its acceleration? Change in velocity per unit time is equal to 9.8 meter per second divided by 1 second is equal to 9.8 meter per second square. So, acceleration of the body due to the gravity is equal to 9.8 meter per second square. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.